Professionals are a bunch of dummies. Well, sometimes I watch something about dinosaurs. Often I watch stuff about dinosaurs, and I watch these things and I go, man, these professionals are dummies. Now, the example we're going to use today is Spinosaur. Sorry about that. I was holding this in the wrong position, and as a result, it was disconnecting. Anyway, Spinosaur, well, it's got a spine along its back with a big old, they call it a sail, but it's really not. And now, watching these shows, they say things like, there's no land animal today with any sort of a structure like that. You're right, there is no land animal like that today with a structure like that. Now, don't get me wrong, we got animals like the bison. It's got a few longer vertebrae on its neck and in its shoulder blade because it does have a hump. And there's a few other animals similar to that do have humps. But such a large structure, that's absolutely not the point of it. Do we have animals alive today that have spinal structures? Yes, we do. Are there a lot of them? Yes, there are. There are estimated between 2 and 30. That's a lot of area in there. That's a lot of different numbers. Between 2 million and 30 million species of fish that or sea creature that we're just now starting to learn about or find out might possibly exist. There's a lot of ocean we have not explored. We've explored more of the surface of the moon than our own oceans. So, we've got some lizards that have similar structures. Of course, we've got the water dragon and the iguana, and they have the spines on their dorsal ridge. That's dorsal is the top. It's from the top of the head all the way to the end of the tail. Your spinal column, basically. What all these creatures have in common. Now, the ones with those dermal spikes, like the iguana, if you've ever petted an iguana, those spikes that are on the top, they're not going to hurt you. They're not going to stab you. They're not capable of harming you unless you detach it from the iguana and mount it onto something that's steel or iron or something hard and then stab yourself with it. And that's an awful lot of work. Um, but if they were webbed or had some sort of webbing in between, then, well, that would be a fishing thing, wouldn't it? That'd be well, just like on a betta or a sunfish or any other manner of fish, they all have that dorsal ridge. Nearly all of them. Dolphins, they have a dorsal fin. Whales, many of them have a dorsal fin, but not all. Most of the big ones do not, oddly. Um, they do, but it's not placed in the same place. It's much further back. On a whale, though, I mean, they're not necessarily going that fast. They don't need anything big. For something like a spinosaur, if it's going to be using its tail for swimming, and it would have, um, then it's going to need to keep its snout pointed, straight forward still. I mean, it's kind of like in a fighter plane. If you got your nose pointed at what you're shooting at or what you're biting at, and you keep your nose there and you get up close and you bite it. But of course, if you've got a tail that's going back and forth behind you, you're going to need to stabilize it from going back and forth because it's going to transfer that into your head. And then you're doing this as you're going forward. And, that makes it difficult to use anything close to or similar to echolocation. It makes it difficult to see, even if you have a secondary eyelid, like many animals that are both land and seaborne. They have a second eyelid that can protect their eyes underwater, but they can still see through. That's not going to do you any good because you're moving quickly. What you should optimally do is keep your nose straight. And what that dorsal ridge does is as your tail is moving back and forth, that ridge catches the water on either side and helps to prevent you from, you know, becoming uneven on both ends. Kind of similar to, those clacker balls that they used to have on their desks in the 90s and early 2000s. There's like 5 balls lined up, and you take one from the left-hand side and you let it go, and it slides over and hits all the balls, but only one of them on the other side goes up, and then it comes back. You've seen it. It's kind of similar. Whatever action you got has a equal and opposite reaction. If you're going to move your tail one direction, your head's going to go the other. That dorsal ridge isn't going to do you any good out of the water. All that's going to do is make you slightly top heavy. It's not going to create very much resistance as far as keeping you steady and keeping you going forward. Not on land anyway. Matter of fact, wind would probably catch that, and that would make you easy to prey on, because if it gets super windy, you're going to want to face into or away from the wind so that you don't get blown over or tumbled. Not that anything that massive would have to worry about that, but there is the potential. We know there are a lot of very large objects that have ended up on land without any aerodynamic qualities whatsoever. We also got to talk about the body shape. It had kind of a shallow diamond shape cross section of its body. One of the reasons for that is because you want it to be wide so that you can actually stabilize in the water, as opposed to thin. Wider is better. That's why a lot of land-borne theropods, they're actually pretty thin of chest. The chest is thin, but it's long. All right, a human, you can kind of think of our chest. If you were to cut me right across here and look down into the cavity, and you were to look at my ribs, it's kind of an oval shape, sort of, ain't it? But it's very short from the backbone to the chest plate. On a land-borne theropod, it's actually going to be further out. There's going to be more distance between the backbone and the chest plate than there is in between the ribs of one side and the other. Now, on something that's going to need to have stability, like, a sea type of creature, a fishing kind of creature, and of course, that's not the part that most of these sites are debating now. Most of these sites, it's not that they're debating that they were fishers. It's not that they're debating anything about that part, or even that they're debating the hydrodynamic qualities and properties of its body shape. It's the fins themselves. Some people have suggested it might be an air bladder. No. As far as the muscular structure, what purpose would that muscle need to be up there? There's none. As far as an air bladder, I can understand why people might think that, especially if it's a waterborne creature. But then again, what purpose would it need for those? Its body is already created so that it can float and be stable. The argument is what those spines were for. And a lot of people's argument is that it's for display, for mating rituals, or for cooling them down or heating them up, which most of those have already been shown with some of our recent fossils to be just complete crap. The biggest one out of all of the complete crap scenario is the idea for display. Now, your body is not going to create something just for display like that. All of the displays that we have on animals, fancy feathers and fancy types of feathers and fancy refractory feathers and all this kind of stuff, all of that we have started off as something much simpler for a much simpler purpose. The original feathers that we have, they're not feathers. It's basically like, well, you've seen a baby, a baby chick, right? A baby chicken. It's furry all over. There's no actual feathers. And a lot of dinosaurs had the same thing going on. They would have looked like they were covered in fur. It's actually a type of feather, but unless you're up close pulling those things off of it, good luck. You see something that big, it doesn't matter if it's covered in feathers or not, you're going to be afraid of it. Kind of like if you get attacked by one of them cassowaries, they've been known to kill people. So stay away from them. Turkeys will fuck you up. Stay away from them. There's a lot of different animals, including geese, that'll fight back despite the fact they have feathers. And of course, they're not that big. So when you think about how not scary a real velociraptor would be, like, you guys have seen the Jurassic Park movies, a real velociraptor is the size of a turkey. Are you afraid of a turkey? No. Most of you have only seen one on the dinner table already prepared or on TV. You've never seen an actual turkey. You've never had to deal with an actual turkey with a bad attitude, especially during breeding season. Now, with that spinal ridge, with most seaborne creatures, coloration is not gender is similar. Gender is all bright and shiny, but for the most part, under the sea, same as above the sea, bright coloration denotes poison. It denotes toxins, it denotes neurotoxins, it denotes all sorts of stuff you don't want to be associated with. But then again, so does you know what? You are stuck with just speculation on that. However, the one thing that is not speculation is that a spine like that is specifically for hunting underwater. It's specifically for quick, straightforward. And that includes even if it's a duck or a goose with a bent S-shaped neck to it, sticking its head underwater or even dunking itself entirely in order to get its prey. It wants to keep it straight, makes it easier to swallow, and also reduces your chance of getting a strain on your own neck. Alright, so I know this ain't got a whole hell of a lot to do with my channel, but it does have to do a whole hell of a lot with a lot of my interests. I like the way things work. Whether that be a body, human body, dinosaur body, snake body, or even just a body of water. I like learning. Alright, good to be with you. Thanks for coming to visit. Stay out of trouble or don't get caught. Remember, you are your brother's keeper. And, you know the rest.